Hi, welcome back to another video. In this video, I will try to control our Arduino board, which is the Arduino Uno that you can see on the board here, from the computer using Python. Normally, we can interact with our Arduino board through the Arduino application. So I will turn on the Arduino application, which is very common. Somehow I feel like maybe in Python they will give us some more command and we can easily handle the data that we collected from our board in our computer using Python instead of writing something in the Arduino platform. So in order to do so, the first step that we need to do is we need to install or we need to upload our standard formatter into our board. To do so, let's assume that we have a new one. Let's say this is my totally new platform Arduino, right? There's nothing special about it. So the first thing that we have to do is that we go to the File tab, go to Examples. Okay, let's have a summary. The summary in order to connect our Arduino board to our computer so that we can communicate with the board using Python. The first step is that we need to upload the formatter into our Arduino board. Formatter is like a protocol already set up, and the protocol set up in order for us to communicate between our computer using Python and the Arduino. And the second step, after we upload the formatter to our board, the second step would be we need to install a package compatible with the formatter in our Python environment. And the third step, we start to interact or we communicate with the board from our Python. So now let's go to the first step, which is upload the formatter to our board. Okay. Let me wait for a minute. Yes. So when you open the Arduino platform, we need to determine like on which COM our Arduino is connected to. At the moment, my Arduino is off. I have not connected to my computer yet. Now I will do it. Let's connect it to computer. Okay. Now the Arduino board is connected. You can see that the LED here is on to indicate that the board is connected to my computer. Now let's see which COM the board is connected to. We can go to Tool and we can see port, and we can see there's the COM 11 and it's indicated Arduino Uno. And of course we need to choose the board Arduino Uno to be compatible with the board. And after that we can go to File tab, go to Examples, and we go to Formatter. And from Formatter we will choose Standard Formatter. Yes, this is what we have here. We can start to upload this file to our board and we wait. While waiting, we can open the Python environment. And the Python environment that I choose is the Spider. To install Spider for programming Python, or you can use whatever IDE for Python, for example like PyCharm or VS Code, but I prefer to use Spider since it's quite friendly for Python coder. So to install Spider, usually we need to install Anaconda, and you can search that in the Google, or you can see it in my description section of this video. And now I will open the Spider. so that we can prepare for our second step, where we need to install a compatible package of formatter in our Python, so that we can communicate with the board using Python in our computer. Now let's see whether the uploading of the formatter to our board is completed. Yes, it's completed. Now let's check our board. It seems fine. It seems fine. Done uploading and everything looks good. And this is Spider. A quick introduction to Spider. Here is your Python script. You can see this is a file for writing your Python commands, and this console, it will for this one it will show many things like plots, variable explorer, and plots are very important when you code Python. And here is the console where you can interact directly with your Python environment. For example, if I type like 1 plus 1, you can press enter and you got the 2. It's just an introduction to the Spider, to the environment. And now we need to have a project, Python project. We go to project, we choose new project, and we can choose location. I will have a pause where I need to choose my specific location, and after that we will return back to the video. Okay, I have chosen the location for my project, and the thing that we have to pay attention first is we want to create a new project, so we choose new directory, and then we enter our project name. For example, I will say Python Arduino trial 2. It depends on you about the name, whatever name you like. And then we choose empty project. Empty project just means when we create such a project, there will be no files inside. Now press create and you will see here is the project folder that we have created using Spider, and it's totally empty. For this file temp.python, it doesn't belong to our project. You can see in the directory here, it doesn't belong to our project. We can close it, but it would not disappear. This is like a default function of Spider. Doesn't matter, we just need to click into our created project and we right click, we choose new, we choose file, and of course the directory is inside the project that we have created using Spider, Python Arduino trial 2. Now we can enter the file name. So let's say we will try with the trial number 1, and the file name should have the expansion .py, so it can be recognized as a Python file. In order to check whether it's a Python file or not, we can start to type a very random Python command. I would choose a very basic one, which is print hello world. Now let's press run here. We should see something. If the file is really Python, we should see the result printed in our console. Okay, now the second step, that we need to import or we need to install a package which is corresponding to the formatter in our Python, so that package and the formatter on our board will create a compatible channel for us to communicate with the board from this Python script. And I searched in Google, and I also put the reference in the video description. Please check it out if you want to. But I already know that we need to install a package named PyFormatter. In order to install a package in our Python environment, we need to go to the console and we type pip install and we write down our package, which is PyFormatter, and you can see there's the corresponding formatter. With the formatter, the standard formatter that we have uploaded to our Arduino. Now let's enter. When we press enter and it starts to run, you can see that this one shows it's running, and when the command has been finished, this one turns to be gray. Okay, now we can see that the installation seems to be successful, but there will be one thing I want to show. To show that, I will need to reinstall my PyFormatter, since it's very important. And in order to do so, I will need to delete, or I need to uninstall my PyFormatter. I will try to do so by, we can just choose this command, copy and paste here, and we type uninstall the package and we press enter. We wait for a little while to see whether the command runs successfully. We will wait for a little while and we will see. It seems like the command doesn't run properly, so I can just maybe stop the command and go to the place where they install the PyFormatter. I know that it will be in the directory as following: my computer, and C users, and then it will be the login name of your computer. Mine is Dell, and we search for app data folder. We go to roaming, we go to Python, and this one is where our formatter package is installed. We just have to shift delete and we permanently delete this folder. It means we uninstalled our package. So now let's go back to a spider and we'll do one thing in order to, I want to show something. Let's go to the edit system environment. We type edit the system environment variables. We choose it and we go to environment variables, and we need to choose the variable path. We choose edit. I want to delete this one. Delete it and we press OK. 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 I will need to restart my computer in order to make the addition to my environment path change in my computer. So I will get back after I restart my computer. We will reinstall the PyFormatter and we type in the command !pip install PyFormatter, and we wait a little while for the package to be installed in our environment. Okay, this is what I want to show, especially this warning. If you encounter this warning, it means even though that you already installed the PyFormatter, but it might not be possible for you to use that package in this Python code. Our spider or our Python environment doesn't recognize the package that we installed. So to make our Python environment or the spider recognize the package that we just installed, we will go to, as they recommend, we need to add this directory to the path. In order to understand what's the meaning of path, please see the reference that I put in the video description. They explain clearly the meaning and why knowing the path is important to run some application, some package. Again, we will need to search for edit the system environment variables. We just need to type edit and it will automatically recommend the thing that we need to find. After that, we will go to environment variables. We choose the path variable. We choose edit and we will click on new. We will paste this directory in the new thing. Okay, where's my setting? Yeah, it's here. So we click new again, we paste in the directory, we click OK. But not yet. We need to move this one up to the top in order to make sure that the package is recognized when the Python environment started. So now let's press OK, OK, OK. And after we edit the path of the system of our computer, we need to restart our computer again. Okay, after restarting our computer, when installing the Py formatter, now we can move to the third step where we start to coding in our Python script so we can communicate with the Arduino board. To do so, I will want to minimize the Python. Okay, minimize the spider window so we can also see our board. Now this is our board. For the script, I already prepared the script in the description of the video. Please check the description to copy the code. So I will just copy paste from this one to our spider. Okay, now let's check our board. Okay, it's still here and everything seems to be in place to test out our Python code. So for the Python code, it seems quite similar to what we do in the Arduino platform. First, we need to create a board variable where we identify that the Arduino is connected to the COM11. The same when we determine the port of our Arduino connected to our computer in the Arduino platform. And after that, we will start to demand or control the board from our Python script. So this is infinite loop. Inside the infinite loop, first we will turn on the digital pin 13. The digital pin 13 on the board is the LED over here. So we turn it on for 1 second and then we turn it off for 1 second. So it's like we want to blink the LED from our computer. So now we control the board from our Python, not from the Arduino platform. We don't code things in Arduino platform, but we coding from our Python script. We will run it. Now when we run it here, the Python code running and everything seems to be okay. You can see that the LED here starts to, what is this? It blinks each second. It's on for 1 second and then it's off for 1 second, as we expect. So now our Python is communicating to the board. To know that whether the communication is happening, you can see the receiving LED here sometimes blinks on and off. It means our board receives the message from our computer to blink the LED. So it's quite different when we do the blinking program in our Arduino platform. When we do the blinking program in Arduino platform, we'll code the code and then we upload into the board. So the code will be inside the board and the board will just reference to the code stored in its memory to blink the LED. However, in this case, the code is not loaded into the memory of the board, but we are controlling the board directly from our Python script. So whenever the Python say, okay, please turn it on, then the board receives the message, it turns on the LED. And when the Python send the message, please turn the LED off, the board also receives the message and it turns it off. So that's the end about introduction how to communicate with the Arduino board using Python script in the computer. With this way we can put in, like, we can connect some sensors to our board and collecting data with our Python, and we can start to process that data in Python. I think it's more like more friendly and more convenient to process the data in Python rather than in the Arduino platform code. Okay, let's stop. I will stop the program from here. And when we stop, what happens? The LED is not off or on anymore. So we stop communicating with the board, so the board will stay in the state that it just received from the last message. Now if we want to run the program again, let's see whether we are able to do that. We run it. Now we have a serial exception. The permission is denied. To fix this problem, we go back to the Arduino platform and we re-upload the standard formatter to our board and wait and see. Okay, an error occurred also. There's the access denied. To solve this problem, the easiest way is to plug in and plug out our board. Plug in and plug out, and then I plug in again. Now, after plug in the board, I will try to first upload the standard formatter to the board again. And you can see that the error earlier about access denied now fixed. And we should wait for everything settled down in our board. Okay, now everything is settled. We go back to our Spider environment or the Python IDE, and then we run the Python script to control the board again. Okay, now the Python is communicated to our board to control the LED. Now let's stop it one more time. Okay, it is additional information. Example, you somehow accidentally delete this project from the Spider environment. Right click and we delete it. Okay, so it disappears. How to open the project again? We go to project, we go to new project, and we choose existing directory, and we go to the directory that you have created the Spider or the Python project earlier. I will need to stop the video for a while to go to the location that I have created the project in this video, and then I will start the recording again. Okay, I again open the location of the project that I created earlier. You don't need to enter the project name again because we opened an existing directory, and we just need to create, and we go back to the folder that we created earlier, also the file inside the folder, which is this one. So now we can again upload, try to run the code one more time, and yes, it runs normally. You can see here. So this is the end. You can try to like change the sleep time. The sleep time is to control like how long you want to put the LED in the on state or put the LED in the off state. Sleep means, okay, I want to turn on the LED on the board and then I don't communicate anymore, so the board will keep the LED on for 1 second when the Python code sleep for 1 second. And next, the Python communicates to the board saying, I want to turn the LED off. The board turns the LED off, and then the Python goes to sleep for 1 second. So within that 1 second, the board doesn't do anything to the LED, and the LED off state is still kept for 1 second until the next command in the Python. I think this is the end of the video about how to control the board from the Python, and I hope that it's useful. If you find that it's useful, or if you find something wrong, please give me a like or give me a comment in the comment section, and give me a like or subscribe if you find the video is helpful. Thank you so much, and maybe see you in the next video. Goodbye.